lecture at some point after the Easter break. Now, remember, this is what we call modern international trade theory, and it takes into account that there's lots of trade that takes place at the intra-industry level. So this is really using the idea that assuming constant returns to scale is not a good assumption in many industries. And so once one allows for increasing returns to scale, and remember, the result of this assumption is that a greater quantity is always going to reduce average costs. But it's going to make sense to actually trade with other nations, just for the simple fact that each nation will now be allowed to produce a small range of the products that people want at a lower cost than if it tried to produce everything. The huge advantage is not we are specially endowed with land, or we are specially endowed with skilled labour. And here the advantage is an advantage of size. I am able to produce at a low cost because I'm producing not just for my tiny Luxembourg market, so I'm producing for the whole of the European Union with more than 350 million people. Yeah? And so this is what Krugman and other people in the late 70s and early 80s theorized, and it has become part of modern trade theory. So we were here last week, so I was just, this is really, you're going to see it's a very simple model that can be illustrated with two curves, but it captures the basic ideas very neatly. So this is the demand, remember, for a particular variety. So I was talking about cars, so this is a variety of cars within the range of, say, £20,000 to £22,000. We're going to have a variety of cars, and they're all going to be competing for the households that wanted to buy cars within that price range. And so what we have here is that there is going to be a certain size of the market which is captured by the sales here, and in equilibrium, if all the firms are the same, yes, they face a downward sloping demand, but ultimately, if the price set by firm I, this, is equal to the price set by all the other firms, the typical firm, then that P is going to be equal to pi bar. And in the end, that should not be too surprising. The quantity sold of a particular make is just going to be equal to, the value that is sold by a particular make is just going to be equal to the total sales in that industry, so the S divided by the number of makes, so the number of varieties or products out there. And so as you can see, this means that there's going to be a relation between the average cost of producing a unit, so a car, and how much you're selling. And that relation comes basically from our average cost function. That, remember, shows that there are increasing returns to scale, because even though the marginal cost of production is that little c, and that's not changing over time, so it's constant, you have that fixed cost, that f, that is being diluted or distributed over ever more cars as you produce more. So as you can see, if you produce a larger quantity, you will be able to produce the car at a lower average cost, because you distribute those fixed costs over an ever larger quantity. So that's the first relation you're going to have on your diagram. So if you have N on the horizontal axis and AC on the vertical axis, as you can see, this is obviously just a line, has a slope of F over S, and has vertical intercept of little c. Yeah? Now, for purposes of what happens with trade, notice that as the value of the market increases, so as that S increases, so think of going from your country, let's say Italy, to now the whole of the European Union, yeah? As the size of the market increases, there's going to that curve is going to pivot downwards around that point 0 C. Yeah? So basically the size of the market is affects the slope of your line, and as S increases, this slope decreases, so the curve becomes flatter. Now the other curve is actually derived from simple profit maximization, and it's very, very simple, so you've seen this many times in the past. This is a firm with some market power, so you either maximize by choosing the quantity or you maximize by choosing the price. Ultimately, what you're doing, of course, is you're choosing a point on your demand. So the demand for your variety is given by the prices set by all the other rivals and by the size of the market. But once you know that your demand, you're choosing a point. And what we're doing here is to look at the point that maximizes the firm's profit. So, as always, the profit is equal to revenue minus cost. The cost, remember, has that variable component which is equal to C times Q, and then it has the fixed component which is this F here. So that's why the C is equal to C times little, the capital C is equal to little c times Q plus F. Yeah? And so it can be written like this. And as you can see, now when you're maximizing, you have to use something that is straightforward, which is the product rule. So P appears here and appears there. So you need to differentiate this bit with respect to P, which is 1, times that, and then plus this bit times the derivative of this with respect to P, which is obviously S times B times minus 1. Yeah? So are you okay with this? Yeah? This is just differentiating a simple product that depends on P's here and there. So you have that, you can rewrite it like this, and you get something which should be quite intuitive. In the end, your price will have to be greater than the marginal cost. And that's obvious because otherwise you will not be able to recover those fixed costs. So you have a market power, so you're able to set the price above the marginal cost, but the extent to which you have market power depends crucially on the number of varieties out there. For a given market size, as determined by the S, that's the total value of sales, the greater the number of varieties out there of cars, the smaller your residual demand. That is, the smaller the demand for your variety. And that means, of course, that if you want to sell, you will have to set a lower price than before. So this is well captured by this expression here. The higher the N, the closer your price would be to the marginal cost. Yeah? And of course, this also means that if that F were really, really tiny, so that we would converge to constant returns to scale. So if that fixed cost were tiny, we would be converging to constant returns to scale, and we would get price equals marginal cost, as you know from your first year. Yeah? So that curve is also can also be represented on a diagram where we have N on the horizontal axis and now P on the vertical axis. And of course, in this case, because N is there, the curve is going to be downward sloping. So as N increases, so as this denominator increases, the whole thing becomes smaller, so P goes down. So N and P are negatively related, and you get, I'll show you the diagram later on. And so now you have these two conditions. One would simply say, this is what a profit maximization firm would do. It would set a price equal to C plus 1 over Bn. The other condition is to say, for a given number of firms and an average cost function, there's going to be an upward sloping relation between the average cost and N, yeah? And the logic being that for a given number of sales, the greater the number of firms, the smaller the market share of a particular firm. And if that firm has a small market share, it will not be selling much, hence its average cost will be higher. Yeah? And then we impose a standard condition in economics, which is to say, why would some firm have a big advantage over other firm in setting up this sort of business? So we allow for people to fight for these economic profits. Remember, they're profits above normal, so you're getting rates of return above normal. And so in equilibrium, those profits should be driven down to zero. And that means effectively that even though you will be setting a price above the marginal cost, in the long run equilibrium, you should only be recovering your full costs. So that the condition that profits are equal to zero is of course exactly the same thing as price equals average cost. Yeah. So if your price is equal to your average cost, of course you cannot be making money. Yeah. So in that case, so you equalize the two expressions we had in the previous slides, so 5 and 6, and you get that there's going to be an equilibrium number of firms, which is determined by that equation 7. And this equation 7 is actually very intuitive. It's telling you the number of firms that can exist in a market is going to be a positive function of the size of the market relative to the fixed costs, or relative to the sunk cost of setting up the business. Yeah. So one would expect that if you have a very small market that is closed to trade, such as say the Norwegian market, then in that country one should have a small number of firms operating, whereas in China, a market that is hundreds of times greater than the Norwegian market, all else being the same, one should expect to have many more firms operating in that industry. Yeah? So this is all else being the same, that's what you get in that equation 7. So the next thing we do really is so this is the representation on a diagram, and now the next thing we do is to say, what happens when we open up a country to trade? Yeah? So just a recap, the upward sloping average cost relation between number of firms in the industry and the average cost. So the greater the number of firms, the smaller the number of units sold by one firm, hence the higher the average cost. Remember there are increasing returns, or in other words, the average cost decreases with the quantity produced. This downward sloping relation reflects the extent to which more firms increase competition in the market, and therefore reduces the market power. So more firms reduce the price, and then in equilibrium, prices measured on the vertical axis, blue curve, will have to be equal to the average cost measured on the vertical axis, red curve line, and you get this number of firms into, it's the only number of firms that it's compatible with long-run zero economic profits. So this means that for whatever reason there is excess entry, so if you're sort of there, then there would be obviously many firms making losses, and they would start leaving. So as you can see, price is here, average cost is there, they're obviously making losses. They would start leaving the industry until you reach this long-run equilibrium. And likewise for N1, in this case there would be too few firms, and the profit motive would be such that the more firms would enter until you reach that equilibrium E. And now what we have basically is to say, let's open up this market to trade, and the open up of the market to trade is very simply seen as an increase in that S. Now the S, the sales, are no longer just how much my home consumers are buying. This could potentially be how much the whole of the European Union consumers are buying. And this, as you can see, especially for a tiny country in Europe, such as Norway, Portugal, and so on, this is a huge difference. I mean, if you think about the four more populous countries in Europe, Germany, UK, France, and Italy, then the difference is obviously it's